Can you see my screen?
Yes.
Yes. Okay. So today I am going to make a presentation about two topics which are related to recent implementations in MetaPath, namely the common fragments and the kinetic data layer. I have two separate presentations for both of them. So now I'm going to the first presentation, which is about the common fragments. As most of you know, probably Markush structures provide a way for a more general representation of chemical structures by using so-called common fragments. Here in LMC, during the years, we extended the original set of common fragments, first in order to have more flexibility in describing the variety of the cases that we met in practice, and also, on the other hand, in order to be able to use these common fragments for generation or storage of structures and for searching. Here in the presentation, I will show you the types of common fragments that we have now, and then I will make a practical demonstration how we can use a positional fragment in order to create a metabolite, and also how we can use an enumeration fragment in order to make a search. Later on, I will explain in more details what they mean. Why we choose the positional fragment, just because positional fragments cover the majority of the cases that you will meet in the literature sources. And also the enumeration and chain fragments are the ones that are mostly used in order to make some search. The implementation of common fragments in MetaPath was funded by BSF several months ago. So till the beginning of this year, they are already available to the public. Here on this slide, you can see a snapshot from a literature source with Markush structure. So the question that comes here is, can we use such Markush structures in MetaPath? Till recently, we adopted an approach in which we entered just one structure as a representative structure and put a special mark as an indication that this structure is expertly defined, not as it exactly in the literature source. But in this manner, we had two drawbacks. The first one is that the user needs some experience in order to assess which is the most probable representation of our Markush structure. And the second one is that in this manner we already are not consistent with the literature source. This is why we were asked to implement common fragments in MetaPath. Generally, a Markush structure has two parts. One is the fixed part or scaffold, and the other is the variable parts, which either could be attached to different sides of the scaffold or which may represent different structures. For example, here you may have an alkyl groups with different number of carbon atoms. As a part of our works, we extended the smiles notation that is used in MetaPath and also in WASI software, in order to be able to represent these Markush structures. Here you can see the smiles that correspond to the structure on the left. Of course, it seems very intimidating, but the good news here is that you don't need to write all this stuff, and even you don't need to understand every character what means. The system just generates the smiles automatically when you are in the 2D editor and when you draw your common fragment and the structure. Once you have the structure entered into the system, actually you already represent the whole set of possible individual realizations which stand for this Markush structure, or simply you are entering this, but you have in the program all this set of individual structures. They are created automatically when you enter a structure, and they are there for future visualization, or when you make a search, the system checks any individual structure in order to see if it will make the search criteria or not. As I said, you can also use these Markush structures in searches. Of course, in the previous versions, you also can make a search for such type of structures, but it is more difficult to enter any individual member and to combine them logically with and or clauses. So this Markush structure with common fragments is a more easy and more elegant way in order to achieve the same search results. So what are the types of common fragments that we have? First is the enumeration types, when different fragments can stand here on your scaffold. The chain fragments is the case when you can create homological isomers. Bond migration is the case when you have a double bond running through a chain of carbons. Cyclic fragment is used to display structures that contain many cycles. You just will define the type of the cycles. I mean 5 or 6 atom, and also the number of the cycles. The positional fragment that I will demonstrate in a minute is the case when you have a fragment that could be attached on a different sides of the scaffold, and I will not list all of these structures now. As I said already, we can use these common fragments in order either to store structures or for searching, and some of them can be used only for generation or for storing structures, like bond migration and positional chain. Also can be used only for searching, like cyclic and exhaust fragment, but some of them can be used for both purposes. Our next section here is just a refreshment of the basic functionalities of the 2D editor, but I believe all of you know them, so let me skip it and go directly to the practical examples.
Sorry to interrupt you. Is there any way this label to be minimized or what, Rick? Yeah.
Okay. So our examples are, first one is an illustration of positional type fragment for creating a metabolite. The positional type was when we have a fragment that could be attached on different sides of the scaffold. And the next example will be illustration of using the enumeration type for searching purposes. Sorry. Here is the snapshot from the literature that we used in order to make our first case. This is the parent chemical. And you can see that there are several metabolites that have different groups attached to the benzene ring. I'll now will create the first case when we have a hydroxy group that can be attached on these three atoms on the benzene ring. And now I will switch to MetaPath to show you how this can be done. I am ready here with my parent. I would like here to say that this is just a demo. I will make it relatively fast. If you want to follow these steps, you can use this presentation as a source of information. It is available on our site, and it has very detailed description step by step how you can create the fragment and so on. And of course, you can ask us for some training if you need. So this is just a demo. And let's make our metabolite now. I am doing what I will do if I have just a regular metabolite. But here, when I'm on 2D editor, I will go on this section for the common fragments. And now, first, I will create my new fragment. I will say that it is a positional fragment with a single connection. Here I will need to define it, and the hydroxy group is defined by this oxygen atom. Now I will use this tool for the free valences in order to specify a single bond that will be used our fragment to be attached to the scaffold. And when my fragment is ready, I will add it here in the library. Once this fragment is here, later on you can use it. You don't need to define fragments every time that you have a new structure that uses it. And also, if you have a case when you have 2 or more fragments, you can add it here in the library. But now I am already done, so I will go to the scaffold now. I will take my fragment. I will attach it to the scaffold. I will say that it will appear only once. And the last thing that I need to do is to specify the position where the fragment will be attached. By default, all atoms for the benzene rings are selected. So here I need to unselect some of them. And now I am already done. My metabolite is ready. And I can add it into the database. Here I can use this functionality to display the individual structures. You can see this hydroxy group appears on these 3 sides of the benzene ring. When you do the similar exercise for all metabolites, you will have the whole map, and you can see that each of these metabolites has different representatives here and here. And if you don't have a Markush type structure, you just don't see here this display individual smiles option here. So this was our example with adding a new metabolite using a positional fragment. Now I will show you how to make a search. This is why I will go into the bigger database, and I will switch for a little to the presentation in order to show you what we will search for. Actually, we will search for hydroxy or aldehyde group, which is attached to an aliphatic chain with length between 1 and 3.
Could you get into demo mode, please?
Yes, but I will switch to MetaPath just right now. So I will make the search here, and in order to save time, I have stored this search query, but I will show you here these enumerations. This one is for the two groups, hydroxy and aldehyde group, and this one here is for the aliphatic chain. If I make the search, the system will show all chemicals that meet this search criteria. You can see the hydroxy group. Here is the chain, and if I go through all chemicals, you can see them on the maps. Probably you know that we have such a connection here. So this is what I wanted to show regarding to the common fragments. As you see, they give us first the possibility to be consistent with the literature source, and also it makes easier to define searches. So now let's go to the second presentation, which is about the kinetic data.
Could you just mention that we have a very detailed presentation of what Atana showed, with step by step what we need to do this, So this presentation, I think that will be Atana's.
Yes, I can just show. You can see it. It is very long. You can see these slides that will show you what to do first, second, next, and so on.
I'm wondering if we could open the floor if anyone has any questions